Hello students, in the last class of electric field, actually introduction of electric field, one part of the problem somehow left out in the video, so I am completing the calculation. We are discussing force acting at a point here because of 4 point charges at the corners. Actually it is a continuation of the last class, somehow the one part of the video is missed out, so I am completing it. Just look at that. So total of electric field because of charge number 1 and charge number 4 is given by twice capital Q 4 pi epsilon naught d square cos of theta. What is d written here? This d if you put here, cos theta is from the figure, cos theta is L by d, so that L by d makes us together d cube. So if you put the value of d is calculated here, d is root 5 L by 2. In that way, if you simplify, you will get force acting on the point charge, electric field at point P here because of charge number 1 and 4 in this side, this one. Direction of this direction of this field will be towards right because one part of E4 upward and one part of E1 downward goes cancel. So previously one part present in downward direction because of charge number 2 and charge number 3. Now because of charge number 1 and charge number 4 there is a field towards right. So let me complete the calculation how to find resultant. Okay, look at, actually our drawing is this. There is one resultant field of charge number 2 and 3 in downward direction, and there is one other resultant force because of charge number 1 and 4. Field because of charge number 1 and 4 is this, and field because of charge number 2 and 3 is this. Angle between them is 90 degree. We know any two vectors, if makes some angle theta between them, resultant is under root a square plus b square plus twice ab cos of theta. In this case, these are the two vectors, so it is this square plus this square under root cos of twice ab cos of 90. Since cos of 90, I am not writing that second part. What is E because of 1 4 available? What is E because of 2 3? This is also available. Just put their values, simplify. You should get this answer after simplification. Clear? I am sure you are quite capable of doing the calculation from your side. So this is actually the half part of the problem what we start solving in the last video, meaning electric field lecture number 1. Now this is electric field lecture number 2. Let me continue from this. I am sure you can do calculation by looking at this one. Clear? One field in this side, one field in this side, just you have to find resultant of the two. Now let me come with another question. Okay, you should come with always, you should be always ready with pen and paper. So write the next question. Right, 2 point charges Q and minus twice Q. 2 point charges Q and minus twice Q are kept separated by a distance L. Are kept separated by a distance L. Find electric field due to them. Find electric field due to them at a point. Find electric field due to them at a point at a distance L from both. At a distance L from both. So let me explain. I am sure you are quite capable. I am just explaining it. According to question given, one point charge Q present and another point charge minus 2Q present, and they are separated by a distance L written in the question. According to question, we have to select a point, say somewhere here, which is at a distance L from both. Meaning if you join at a distance L from both, this point where we have to calculate field together forms one equilateral triangle. So we are finding field at this point, say P now. We know how to find field. Field because of a point charge is given by Q by 4 pi epsilon naught r square. So because of this positive charge, if you consider field at this point, we know direction of field is always given by the direction of force acting on a unit positive charge. So that unit positive charge because of Q gets a repulsion like this. E because of Q. And E because of minus twice Q, this is a plus 1 coulomb charge by definition. This minus 2Q will attract it. So it is E because of minus twice Q. Be careful when you write fill, direction to be drawn, value when you write, no need to write plus or minus. So fill because of Q is given by Q by 4 pi epsilon naught L square. Fill because of twice Q, actually minus twice Q when you write, it is twice Q by 4 pi epsilon naught L square. Be careful, plus or minus sign of the charge, no need to write. Instead of that, you should show the direction. Plus minus only contributes to direction. As equilateral triangle, this angle is 60 degree, meaning this angle is 120. So total of these two, meaning the required fill, you can measure by under root E because of Q square plus E because of minus 2Q square plus, here angle is 120 degree, you must write. In the previous case angle is 90 degree, cos 90 0, so not written. It is twice E because of Q, E because of minus twice Q, cos of 120. I am sure you know the value of cos of 120, it is minus half. Just put the value, simplify, you will get the value of electric field. I am ending the calculation here, you should do the simplification from your side. We are discussing how to calculate field because of point charges. Now, all calculation of force and all calculation of field is similar. At the time of doing calculation, you should be considering direction properly. In case of field, direction to be identified by considering the force acting on a unit positive charge. Now, I want to extend this idea further. Clear? Say, now the question is extended from a point charge to a big size object. I am considering a uniformly charged thin rod having charge Q, length L. I want to find field at a point here at some, say, A distance. You write the question first. Previously point charge, now I am extending the idea to a rod. Write the question. Figure shows a thin uniformly charged rod. Figure shows a thin uniformly charged rod of length L carrying charge capital Q. Carrying charge capital Q. Find electric field at point P at a distance. Find electric field at point P at a distance A from the rod. Okay. So question writing is over. I am going for the solution. Look at. We know field is given by a formula like this. Q by 4 pi epsilon naught R square. But be careful, this is the formula for a point charge. Field because of a point charge field because of point charge at a point is given by this formula. But we have to calculate field because of this rod. So for the rod, this formula is not applicable. So what I am going to do, at some x distance from the considered point, let me consider a very small portion. Say I am considering a very small portion dx. Charge present in this dx portion, say dq. So this dq present here will be very small, almost like a point. If point, this formula valid. So field because of this portion I am writing. Clear? Actually you have to find total field. This field only because of this portion. Because this is a point, this formula applicable. So it is dq by 4 pi epsilon naught. This distance is x, so x square. I hope no difficulty in the writing. What is dq? We have to write by unitary method because q amount of charge present uniformly in the rod. So q amount of charge present in the length L, we are interested in charge in dx length. So I am using unitary method. For L length of the rod, charge is q. For unit length q by L, for dx length q by L into dx. Okay. If you put the value of dq here, q by 4 pi epsilon naught L 1 dx by x square. So total electric field I want to measure, it is q by 4 pi epsilon naught L it is integration of dx by x square. So limit important. This x we are measuring from point P, so we can start at A at this point and we have to finish here. So limit of integration is directly or indirectly available. Yeah. So limit of integration is starting from x equal to A and finishing at A plus L. Starting at x equal to A, finishing at A plus L. So E after calculation totally 4 pi epsilon naught L dx by x square on integration minus of 1 by x. Limit A to A plus L. Minus kept outside. Q by 4 pi epsilon naught L. 1 by x left. It is always final minus initial. So it is Q by 4 pi epsilon naught L minus I am putting in, then I am taking LCM. It is A into A plus L. Here it is A plus L minus A. A goes cancel, L and L here also goes cancel. It is Q by 4 pi epsilon naught A into A plus L. This is the fill at point P because of the rod. Clear? So at the time of doing calculation, I am using the basic definition. You can get it by the alternate way like this. Clear? I am just showing the alternate way. If you remember this question, already one question of this kind is done. You have to go through my class serially. Don't jump to a new class. So previously a question of this kind done. If a rod present having charge Q, length L and a point charge, force between them was capital Q small q by 4 pi epsilon naught A into A plus L. This calculation is already available with you. In a video class it is available. Clear? You should go through it. So this force already known. Now by definition, this is the force acting on Q charge. So force acting on Q charge is this. Fill by definition is F by Q. So if you divide this F by Q, we will get the same answer. 4 pi epsilon naught A into A plus L. So we can calculate fill by actual derivation like this, or we can also get it from the idea of force. So calculation of force, if known, calculation of fill is not so difficult. Clear? All problem, whatever calculation or idea of calculation we use for force, same idea of calculation can be used for fill also. Just my advice is, at the time of doing calculation, you should go through each video serially. This is the second class of electrostat where we are discussing electric field. Clear? Now you should, after completing, you should wait for the third lecture of electric field. Thank you.